Okay, I think, okay, we should be live. Let me just check the, what is this now? Let me just check. Within the studio. Yeah. Okay. I'll change dashboard. Okay, so we're live here. We have excellent connection. I think the chat should work in the OBS. So that's I think. So okay, today we are doing something a little bit different. I now realize that there is a code forces round in like 30 minutes probably or something, maybe a lot less, maybe it even started, but I don't care about that. Wow, the server is down. Wow, interesting. Okay, whatever. We don't care about that. Okay, we care about learning some stuff and developing our node engine. So I had the question in the chat as well. Hello, watching your live stream. Enjoy the content you put. I like the FF Algo live stream. Thank you so much. Hi. We are doing a little bit different. I will try to change I'm sorry for the microphone again, guys. I don't have my original my microphone that I'm using for recording the videos. This is a cheaper one. So yeah, that's I need to buy a new microphone. Yeah, but so the thing is that I will try to like do different kind of projects and show you guys different kind of like different languages, different techniques of coding, different mostly production stuff, that like some libraries that we're coding, some open source stuff, some closed source stuff, mostly in Python, C++, TypeScript, but also we will code something in Rust, in safe C++, in I would want maybe someday to code something in some more obscure languages like Clojure or some other functional languages, Haskell maybe. Okay, so today, no, so you don't want to be like me. No, I spent too much time coding, and this is something. Yeah, I would like to spend some time doing some other stuff, but okay. So we're today doing something a little bit different, and this is a node engine that I'm developing. This is actually for work, but it's my own little pet project that I'm developing. And essentially what it allows you to do is it allows you to do graphs. And like you have like different kind of nodes that are implemented that like my team, it's not my team, it's like my colleagues implement different kind of functions, and all of these functions live in separate DLL files. So there are like, I don't know, 12 DLL files, and all of them are loaded here. And all of these functions live like in one DLL file. And then what you do is like you add like some, I don't know, some inputs, whatever database, let's say some string, device name, and then let me just zoom in maybe for you guys to see a little bit. And then you want to output some outputs and configure kind of a graph that at the end, like, you could add some other nodes. You could add a string list node with couple of strings. Then, like, you can populate each of these strings, and you can output this list. And if you want to try to output like this is a string list, and you want to put it as a string, it doesn't allow you to do that. So it just allows you to do strings, the same types of terminals. And all of that is like handled within C++. So it's like pure C++. And C, of course, like, I mean, for DLLs. But what is interesting is that, like, we have we have like wrappers for Direct2D, the Direct2D library, which draws all of these kind of things. And I have a wrapper that actually kind of handles the resources of Direct2D. So you have this abstraction and all of these nodes, and like you can combine nodes, and you can there are two types of nodes. There are like auxiliary nodes, and there are nodes that live in DLL files, and each node has its instance. And you can do other stuff, like you can import some like already created graphs. You can like export, you can toggle some debug mode, and it like this is a 4K monitor, and it renders it like 4 samples. And Direct2D, it seems like we don't have it optimized as well as we can. And this is what I want to touch today, like some graphical optimizations that need to be done in order this to be a lot faster. Direct2D is essentially living on top of Direct3D, and what is this? No, this is something. Okay. So Direct2D is like an abstraction on top of Direct3D, and we have a wrapper on top of this Direct2D, and then we have a do 4K live streaming. The trick is that here I don't have the connection. Maybe in Slovenia, when I come back to Slovenia, I could have the connection, but here it's the connection is very bad. So no way I could stream. I don't even have the connection for 1080p streaming probably, but it's some kind of pulls it together. So the Direct2D, and then the Direct3. So there's the Direct3D, the Direct2D, and then there is our wrapper, and on top of our wrapper is our rendering engine. So it has kind of layers of abstraction, but because it's all like in C++, it's very fast, and the call should be very fast as well. So like essentially what I want is I want to profile some things, and I want to add some things, and I want to make some things faster. This is probably today's goal. So what I found researching for this stream is like there are a lot of things like what you can do to improve the performance, but most of this stuff is like we've already did. So most of like when you are so there are a few things that we need to read from, and it's nice to read the actual documentation instead of just doing ChatGPT stuff. I'm really against ChatGPT, so I mean we'll check ChatGPT out if we need to, but we'll read it here first. So the thing is, direct2D, what it does first, it calls, it encloses all of the rendering commands between the begin draw and end draw. So until end draw is called, so they say after you call begin draw, a context typically builds up a batch of rendering commands, but delays the processing of these rendering commands until one of the statements is true. How can I be a content master whenever it's hard to improve? I'm against GPT also. Yeah. Like the competitive programming, I don't like. I've it's kind of became yeah, let's when we're here and before we start, maybe it's good just to go and just to solve a problem on lead code. You know, like it's the competitive programming is it became either you're grinding for like some interviews or you're grinding code forces, which code forces became just like mathematics. And like if you know mathematics, then if you know like these tricks and this pattern recognition stuff, you'll know like most of the things. I've known people that don't know really competitive programming but know a lot of mathematics, and they're really good. They're like GMs. And so yeah, so that kind of became became just more and more stuff are probably like, I'm not going to open Codeforce now because of the contest, but it more stuff became just pattern recognition. So if you're good at pattern recognition, you just like solve the same ABC problems on Codeforce, and like you're gonna get there. You're given a string. It's more important like consistency than I'm always saying. It's more important consistency than doing a lot of problems at once. Just do like every day, just one problem, and that's it. That's it. After some time, you're gonna just there will be like one day where it clicks, and when it clicks, you'll know like the code forces like patterns, right? Just the same patterns. You're just guessing that something is this, and then you're trying to prove it mathematically. You're giving a string word and a non-negative integer k. Return the total number of substrings of word that contain every vowel at least once, and exactly k consonant. So exactly k, no matter what consonant it is. Okay, so exactly k consonant. So what are the okay, yeah, this is some like brute force with the, you're just having a k window, and then you're trying to see how many vowels does it take to exactly k consonants, because like if you go to a consonant on the left side, you don't have anything on the, yeah, let's say like this, just simple, just simple. So the trick is that like you want to find from k to n, and so the trick is that in the range from I minus k to I, you want to have k no, so you don't, this is at least the minimum, right? So this is the minimum because k cannot be less than that. So if there are a lot of consonants, the total number of substrings of word, well, we can binary search. What is this, right? We can binary search. We can even binary search from I plus k to n. When is this valid case, right? So after some time, this becomes not a valid case. So this prefix 20, I think at least no. No, and vector int 26. This word I. So prefix set I at word at I minus a. I hope there's just English. Plus plus for j26 if I prefix I j, and then you want to like probably binary search from beginning at this beginning at I find the exact occurrence of k, find where k cons are, but since there could be like a lot other things, then there's like the first occurrence where this is k and where this is oh yeah, thank you for the defining of n. Okay, and now since k consonants, so we are looking at this int l is at least this, r is n, then this, and now consonants, let's define a function. Let's define a function where no, let's define another function, sum from L to R on that index I, and then this is the prefix R I minus L is bigger than 0, prefix of L minus 1 I, otherwise 0. And then there's this cons. Let's define a cons function from L to R, where it will just return let's define what are the or let's define vowels maybe. Vowels is string y a e o u for auto vowel and vowels in some I didn't some range, some range LR for minus a. Okay, and then return sum. This is the vowels, and the consonants is just this minus this. The sum, the range of all minus the range of, I mean the range, the size minus vowels. So, okay. So we need to find cons is this range, which is m minus I plus 1, m minus I plus, no, it's not plus 1, m minus I is the range. Yeah, a minus I is the range, then this range is minus vals at I through m, and this is like the consonant, and if consonant is greater than smaller than, so we need smaller than equal to smaller. This is the last time we accept that. This is the last time we accept L. So this is not valid because it's smaller. If it's equal, it will be valid, but it will be valid, and then this will be the last element that it is equal to k. And then you need to find the first element that is equal to k, and then the difference between these two are the actual thing. So okay, let's say that this is like that, right? And we just need to find, this is one binary search, find where k consonants are, and then there is another binary search where we find smaller than k, but then the difference here is that L1 is just L1 plus 1. So L1 plus 1 to so the range is L1 plus 1 to L. This is the range. So L minus L1 plus 1 is the range, maximum of 0 if there's no thing here, and this is current, and ns plus equal current, ns 0. Oh, not an int, but long probably. I don't know if this works, but maybe I've missed something. K0. Oh, K0. K could be 0. K could be 1. Of course, we need to also check what is the shortest that actually contains these values, that actually contains the yeah, okay, that contains at least one of this. Okay, let's see, like this. Let's make a function good, and this is some index I, and we iterate through all of the vowels and say that bool okay is true. Okay is if no, not I, again LR. Okay is if the sum range of L of R of value minus val minus A is greater than 0, return okay. And here we need, this is the first time that this is smaller than k, but also has to be a good function. But also like if L1 if yeah, this here the case, if this is not the case, if L1 smaller, is the consonants is smaller, if it's okay, then I'm not sure if that's okay. Not sure that if that's okay, because here we're testing for the smaller than k, so this is like this is here, and now here we have k consonants up until some point. So this is L1, and then this is like L, right? If smaller or equal than L, than K. And we need to check if if like L is small is K, exactly K, and this is exactly K. So we have to check like this: L1 plus plus if no, we have here there's no, if L1 is good, then L is good as well with consonants. If L1 is good, then L is good. Can I check this? I'm not sure. Here, let's do this. If L1, if so this computation is stupid. I want to make a function which returns like consonants and takes an integer, takes L and R, and returns R minus 1 minus vowel. And now vowels is R is not within this, M is within this. So this is plus 1 here. Plus 1, L and R, consonants here. This is I and I plus M. This is like that. So we were wrong here. I and I plus M. No, it's not I plus M, it's M. Because here we're L is considered this. L is considered this, then we take in, so we say if consonants from I and if consonants from I to L is equal exactly K, and consonant and good from I L y to L minus 1. So okay, so maybe this won't work, but still it's better than original. What is now? Why this doesn't show me anything? This lead code is the most else lr r minus L plus 1. Why did I even constants from 1 to L? Oh, what if L is like if L1 is bigger than n, then just continue. Doesn't really matter. Yeah, so 1 cannot be equal to this. Okay. So it has 0 because nothing is good. Nothing is good. Okay, let's just print a little bit of debug information. L and I promise we solve this problem and we got code actual C++, not this shit. 4. Why is 4? L. Okay, L is 4 because we say, yeah, because all these consonants have to be accounted for. L is 4. 0, 1, 2, 3, 4. Okay, that's cool. L1. L1 is for only this here. L1 has to be, okay, we don't need that now. It has to be smaller than the consonant. Oh, because k is 0. Oh, this is for edge case. K is 0, it means that all of these are just vowels. And this is definitely smaller, and we're looking for the smaller but also the good. Also good. And so if it's not good, no, but we're looking for the smallest L for which this is the case. Here we're not doing this good. Okay, let's think about this. Consonants is what? If this is the case, so it means that I'm if consonants is smaller or equal than k, it means here, let's say here, then I'm putting L and I'm looking for here. Okay, cool. Now here, if smaller consonants is smaller than k and it's not good, I'm putting R here. Instead, what I need to do is, if it's not good, I have to put L here. And then I want to look further. So I want to look until this is good. I want to look until this is good. And this is smaller if this is smaller than k, or it's not good. And then here I don't even need this. Okay, that's correct. From 0 expected, from 0 to 4, the 3 consonants, it's not good. Why is this 3 instead of Good is what? Good was, remember, good was this. Good was this. Good was this. Consonant from L1 was okay, which is correct. And now this is the doesn't apply. Why? Consonants. What if I do this? Cons. Oh, I cannot debug this in, so I have to wait. R1, then this is good. R1. Stupid. Good and R1. Okay, let's see what this does. 0, 1. If it's good, 0. Okay. Okay, this is correct. 0, 0, 0, 1, 0, 1. Maximum of R1 minus R1 minus L plus 1, something like this. No, this is correct, but R1, why is R1 bigger here? Yeah, this is accepted, but I don't like this. I don't know why R1 is bigger. Not sure. I don't want to pause this until I'm sure. C R1 is smaller. The consonants are smaller than K, or it's not good. Consonants is smaller than K, or it's not good. Maybe it is correct. I don't know. I don't know actually. Cannot doubt it is correct, but yeah. But I'm too lazy. Wow, it passed 600 cases. Are these cases so incredibly? What is this case now? Case 2. These so weak test cases? I don't get it. Why is K2 here? A, E, O, U. Here, this is that. So there's like one here. And one here. Expected 3. from 0 to 7, from 0, 0, 1, 2, 3, 4, 5, 6, 7. But why is R smaller than that? Binary search doesn't work here because it's not monotonic. Is it? Is this monotonic? Consonant smaller than K. Consonant smaller than K is true for the beginning, and then and then it's not good, it's true again from the beginning. No, this is monotone. No, this is monotone. I don't understand why R1, L1, R1. Debugging. I don't like this, but I have to solve this problem, and then we go code. Consonants, +1. Maybe missed something. R1 consonants. L1, R1. Oh no, I need meat. I need meat to know what is meat. So from 0 to 5 we go 0, 1, 2, 3, 4, 5. 5 is the mid. From 0 to 5 we say that consonant is 1. That is correct, so it's not good. And then it goes from 0 to 6. Then again, not good. Consonants. Oh, then this is good. This is good. No, this is not good. 0, 1, 2, 3, 4, 5, 6. Oh no, this is good. This is good. And then this has done R2 here. R2 here, and then zero, 7, 6. No, this is L minus R1, right? Yeah. Wait, I don't understand how did this pass if I don't understand how this passed. time limit exceeded. No. What? Stupid. It's just 2 for loops. Not optimizing that shit. Times that. There's not even. There's probably off and solution, but I'm too lazy to write that shit. Okay, I'm just gonna. It's just nlog and solution. Nlog and solution. I will optimize it later. I'm not writing that shit. No. Okay, so let's go code. This I assume this is solved. This is solved. Now if you make a tight loop that nlog n doesn't pass, then that's your problem. Although direct to the okay, so here's the thing. I need to check this. I've lost too much time on the stream doing shit. I need to check this query method. Query method is used to get information from the GPU. Because we want to. So yeah, here's the thing. We have these wrappers, and we want to. Okay, let me just open up. In the direct 3D, we have this graphics device wrapper, which essentially has device context. Since device context has a very well-defined interface, it actually, if you search for device context in the code base, you'll find this interface, of course, which allows you to do stuff, allows you to do with 3D stuff, the 3D stuff, right? But what I want to find, so what I want to search is like device implementation, and here are like the overrides for the interface, right? And there are no overrides where I can create a query. And this is so the only thing I can do is I can create the query on the device itself. So you're querying the device every time you're doing something. You're doing D3D. So create query is only on the device itself. So I have to, in order to access this kind of function through our interface, I have to create. So okay, so here's the thing. mDevice, I cannot access mDevice is this guy here, right? This is a direct 3D device, but there's no way to get get context. There's get context object, but there's no get device. And mDevice is this D3D device, right? So here's what I will do. Here's what I can do. I because this is 3D related, D3D related stuff. It's like no, I don't want to get the device object. I want to create a function where I have create query, And what does this function return actually? Yeah, so I have to go and look up at the documentation. You're giving so you're giving there are two things that it does. It creates the you're calling this function with a query descriptor, and you're calling i3d you're giving a pointer where this query should be, address of a pointer to the query object created. And since all of these objects actually want, do I have access from here to the I objects? I think I have access. So what I can do is, if I go to iShader, this is in the graphics device, and iShader is here. So I can create an interface for iQuery object. Can I move somehow? Like, what I hate about this stuff is that because I'm doing through remote, I have to actually always switch. Okay. This guy here returns a pointer. So if I have a query object, or just query, which is a core object, this query object we should implement this query object somewhere, right? Since it's not only like just I will give you the query object, but there's no creator of this. How do you create? All of these return some, all of these, like, you're giving some pointer to. You're giving pointer to the render target, you're giving pointer to the resource. How do you actually create the, where should this query object live? Essentially, query object, what can you do on a query object? That's a point. That's a valid point. Okay, so here's the documentation. A query is typically executed as shown in the following code. Query descriptor, you're filling the query descriptor structure. You are creating a query from the device, and then you are giving to the device context, you're beginning on top that query. You're issuing a graphics command, and then you're ending the query. And the data, you can get the data out of the query. The query is essentially will help us time stuff, GPU stuff. Yeah. So let me just know, like, I just want to open up the YouTube. I don't have wait. Let me just open. Okay. So here's the thing. What did I click? Okay, here's the thing. Get description. So there's like, I don't think it's like important to implement this whole query structure in a nice, I don't know. I mean, it's nice to have it as an interface. I don't think we're gonna do anything from the interface itself. The query interface inherits from the ID3 asynchronous interface device child. So okay, so what I've learned is that D3D query is D3D query time. Yeah, there's something called query performance timer, and there's something called query timestamp. And what it says, timestamp frequency. Your application can query the GPU timestamp frequency on a per command queue basis. And then it says the return frequency is measured in hertz. If the specified queue doesn't support timestamps, then the API will fail and return eFail. D3D 12, no, we don't have 12 here. We have 11. Enables application to correlate results obtained from timestamp queries with results obtained from the query performance camera, which is enabled by the call get clock calibration. I don't think we need that much calibrate. I mean, I don't think we need that precise thing. I just want to see like how much time does the GPU take on like each draw call and all that stuff. A timestamp is sampled by the GPU at the moment that the GPU is finished with all of the preceding workload. It's the same behavior adopted by Direct3D 11. Yeah, Direct3D 11. This is what Direct3D 11. We have timestamp. Query timestamp. Enum query. Yeah, there are a couple of things here in the query enum. This is not necessarily a representation of the actual ordering. So the okay. This is not, I think, the function that we need, but okay. So let's do this. I don't know if I need an interface here. But what I want for first thing is to try to just, okay, what is this? Graphics device, iGraphics device, this is device context. iGraphics device has all of these: create vertex buffer, create samplers, all of these functions. Okay, yeah, so on the device itself there should be a function, a virtual function, virtual void create query. Okay, so I don't, so let's say we don't know the signature of that function, but and we don't even know what it should return. It should probably return a query object. So can I, no, I cannot just do this because there is a problem there. So I have to return as a query out object like that. And then I have to define as usual, so struct iQuery, which is an object, and we'll know what there will be inside. I have no clue. Okay, get query. So the thing is just to measure what is this time. No, create query. We will create query. We take this kind of signature and we want to implement whichever implements query iGraphics device. Whichever implements iGraphics device. Oh, there's ID3D graphics device, which again is some interface which can be implemented. No, let it be in the iGraphics, and this should go, yeah, this should go at the end, create query. So there are all this stuff. Let's just say here void create query, override. And how are these so yeah, so you're create texture render, and you're putting a render target in, and then you're creating this render target, and you're detaching the Abbey from the render target. So this is the same thing what we're going to do. We are going to do the same thing, but we need to implement because this is that 3.11. We have to go and we have to see where this is implemented, and since it is implemented all the way here, what is this? This is device context. Yeah, all these are min based. So we will have to do here struct struct query, and this kind of implements, oh yeah, we first we need to do struct query implementation, which has is it in the graphics side query? And this implementation is just, we don't know what this implementation is essentially now. But here all we'll have is like, we'll have definitely access to the device somehow, and we'll definitely have to define a which is of type whatever that query type was, the 3D11 query type. No, this is an enum. Whatever type was that? This is a enum. Create queries. What does it return? Create query. Yeah, we'll see. Let me show you here. Okay, we don't know what is this, but this is query object. We are not sure because we don't know the types, but let me just go here. Yeah, query override doesn't override because we need here, we accept. Oh, because we output here, can we do, yeah, can we do a double pointer? Like double pointer query? And then, oh, create query. Yeah, this needs to be a double pointer. This needs to be a pointer, and then we need so like if I look at the M device, right? I'm looking at this is the device itself. I'm looking create the device itself doesn't extend from the M device, but it actually something calls this thing here. The 311 device. This probably we have to call. We have to call this thing. And we have to say create query. And yeah, you see it gives a descriptor and it gives ID 311 query interface. So the pointer here has to be id3d11 query. This has to be the pointer. Oh my god, oh my god. Okay. This has to be the pointer, and this is not a resource. I think there's no, yeah, there's no thing to resource manage this, as far as I know. A query can be created with a query data is typically gathered by issuing query begin command, issuing and then get data to what happened in between the data return get data different depending on the type of query. There are, however, some queries that do not require calls to begin. For a list of possible queries, see D3D query. Yeah, so D3D query gives you a list of possible queries. And then there, like, you can do a timestamp disjoint, occlusion, pipeline statistics, whatever, like SO statistics, probably some object statistics. Okay, but the whole thing is that a query is typically executed involving you're giving a pointer to this to this pointer, right? And the descriptor of the query. So on the query side, what I want to I'll need to issue the query. What I'll need to create the query is a device, which is device graphics device. Do I even have an access to the graphics device here? I'm not kind of sure. Let's see. Device context. From the device context, I can access the device. Who is implementing this? It's implementing the device itself. It's implementing this. So I cannot access the device here, but I can access the interface of the device. Or do I just create on the device itself, and then I just add a query object. I just detach a query object here. Like doing this query object. So you're just doing essentially, yeah, you're just doing mQuery, like, yeah, mQuery is query object. Let's do it this way, simple. So it doesn't have to access the interface of the device. But this query implementation is implementation of the D3D, and yet we don't like that because the graphics interface of this guy here should say you should actually like do this. You should like just get the object empty, and then like have a function that like you're just doing like create query, right? Create something like that. There's this destroy function, but there's also like create, I think. Create functions, yes, there is a create function. So let's just take a look at the proper way to do this. So the proper way, you are supplying a resource manager here for the font, let's say, and you're calling a create function inside. Yeah, so the create function doesn't actually, so you have to pass into the interface itself, but also you're always passing it as some interface. You are not getting anything. Yeah, you're passing here, let's say, an interface, right, to that you're passing a pointer, but some kind of a to this structure. So here no, I don't think it's possible to pass here device, because the device itself, how the device is implemented. iDevice context graphics device, but graphics device is a virtual class. This is a virtual class, and on top of that you have graphics device implementation. But I want to access the graphics device. Graphics device implementation should implement this create query. Okay, so let's say that this create query, let's say, okay, so we want this D3D11 query descriptor, and now we have no idea what this descriptor needs, but it needs two things. It needs a query type and some flags, which we can define. Can I do this, or no? C++ doesn't allow me to do this. So you want D3D11 yeah, because so now I think that, okay, so the D3D11 query is an enum that supports all these queries, right? So I don't like having just like a timestamp query. So here I have to say this. What is the query type? But this is D3D11 specific. D3D11 specific, and thus maybe it's better to create this function in the D3D11 interface instead of in the graphics interface, where I say create query. Instead of here, I go into the D3D11 interface and I say virtual void create query. And now you have to implement this kind of stuff. If you're implementing the 3D11, you have to implement this kind of query type. Since this enum is pretty big to just copy, there's like occlusion, timestamping. Oh, you're adding +1 to the previous. Wow, why? Okay, I don't know why. But okay. Since we have this query here in the graphics in the D3D, we will go and we can say that the descriptor contains this query type, and the second are like some flags. But I don't. What are the flags here? Flags are probably 0 or something default. Does it have a default option? Miscellaneous flags? No. Can't I find flags? So the descriptor. Where is the descriptor? Query descriptor has to be defined here. There's miscellaneous flag. See miscellaneous flag. And there's a what? Tell the hardware that if it is not yet sure if something is hidden, or not to draw it anyway. This is only used with an occlusion predicate. Predication data cannot be returned to your application via get data when using this flag. Okay, this is some obscure flag, a very obscure flag. A year ago this article was created. Very obscure flag, but like this is like some predicate hint which we don't need. We can just do that. And since we have this descriptor, we can give the descriptor, and then there's this object. Yeah, and there's this object. So this object is like, for now I'm just gonna do this core pointer of AD3D11 query. No, it's not query, it's what was it? I forgot. Query. Query implementation is this guy here. Wow. Okay. We go here and let's say that this is a pointer, and we need to give the pointer. Does it return something? It returns an H result, and H result, and the H result, what should the H result be? I think 0. But yeah, the H result just is like, we don't care about that, because we don't even it will never happen. This, I mean, we can maybe get it handled, but this is like, if I think what you just do is like, is there some check that has to be? I don't think so. H result succeeded. There is this succeeded macro. If it is succeeded, yeah, the thing is that, like, if it's not succeeded, we have to return false. And yeah, But this will never happen. This is like out of memory thing, but the memory of this structure is very, very, very minuscule. Okay, so this pointer, and then we create, then we go and we say the following. So the thing is that because this guy here is nope, not this. Where did we have this iQuery? There's so many files. There's so many files. This guy has let it accept this query object. Let it accept this query object for now. Maybe we'll just move this stuff a little bit later, but let it for now accept this query object. And what we can do is just completely here put like a query and then graphics and say it's a core mean base of the implement. Ooh, this should be in an implementation namespace. Yeah, this is an implementation namespace, but the whole thing is that I don't like CaniCare dependency. You know, CaniCare is like a library wrapper for the 2D as well, so I don't quite like that. I think one day I'll just get that dependency out. So should we? Let's do this. Com pointer of this type. Query. Then you just do make self query. And then when you do that, you can then detach the pointer to that object. We're just doing graphics. No, this is not inside graphics. This is inside. What kind of namespace is this here? This is the graphics D3 D11. Graphics D3 D11 query. You get the pointer. You are getting the pointer of this. So this is the object, and then you're doing object detach Abby as iQuery or whatever, and then you are assigning this to that here. So yeah, so who needs Rust? Who needs Rust? Who needs Rust? Who needs Rust? Yeah. Cool. So you're detaching this pointer, and now you have a pointer. Essentially. Okay, now how to use that? Now let's go to the, not the rendering engine, but DX control. Yeah, so the query, what we want to do is we want to make the query. So on the render 3D, what it does, it just calls this function which begins the draw call, renders something, and then ends the draw. Here we kind of just want to experiment what happens if I get a query. What happens? So now I have access to the renderer only. Oh yes, because this is an implementation. Oh no, you can do this, get 3D, right? Let's get the pointer to that guy. I think reference d3d dot. Now you can get device, and what you can do is create. You can't do create query. No, you cannot do as, and then I do d3d device. What was the graphics device d3d something like that. Oh, I don't remember. There's so much dependencies here. This thing was defined here, this guy. Oh, but this guy, yeah, this graphics, maybe in what is the namespace in graphics? Why can't I access this? What? Namespace graphics, no member d3d graphics device. Excuse me? It does have a member. Do I have to include something? Graphics device is already included. Graphics device is already included. Do I have to include something? I render targets. I swap chain. OpenGL swap chain. Device context. Query. So okay, the device context is device context. We don't really quite matter. But the iGraphics device, because we have implemented this create query structure in the other thing, iGraphics device doesn't access that shit. Oh shit. Okay, so it's the same thing as I'm saying. I don't want to. Oh wait, I can do that. Well, here's the thing. If iGraphics device, does it have anything related to? No, the thing is that this is kind of an interface that has nothing to do with D3D. And I don't want to add something here to that interface because it has to be supporting all of the other APIs. So this guy here, iGraphics device, but as D3D graphics device, I've seen something like this. Yeah, of course, I've seen it. Why is this not included though? Had I made mistake? mistake something. Graphics D3D 11. No. No. What is this? Graphics device. Graphics device. Graphics device has this implementation. These implementations like create deferred context. Right here. So they have these creators here. Okay, how do I fix this? How do I fix this? D3D. What does it return here? What is this inline control base on the D3D? Yeah, okay, inline, yeah, control, it just returns the control base. Yeah, let's do this. Device and get device type, get the media context. No, we know that this is 3D, so I just have to say as and then this guy. D3D device D3D graphics device. Let's try to include D3D 11. What was the implementation called? D3D 11 implementation in what is this? Graphics D3D 11 implementation. Will this work? Okay, it does work. So now I can create a query. Now what I want? I want. Oh yeah, I want to create a construct. Okay, for now I'm just gonna do this, but this is only for now. Okay, graphics query. And what I can do is do I have to do that? I don't think I have to do that. No, it has to have a pointer to that guy. Then the other thing is D3D 11 query timestamp. Of what? Why? Argument type query implementation is not compatible with. No, is this implementation? No, this is not implementation. This is this is query implementation. It contains a graphics query. This guy, destructor. Let me look up some example. I don't quite understand why this mean base. Let me look up node engine. I remember I was doing something like this here in the HPP. So output properties, yes, data interfaces, and yeah, this guy is just an interface. This guy is what? This guy is a main base of that interface. Maybe because it's directly a main base of that interface instead of a main base of an implementation. Like this is the implementation, but this is a main base of the interface. Do you have to do that? You have to do that? Like, do you just do like, no, here, let's say command list. Okay, command list. When you're doing create command list, oh, this is can't care. I didn't care about that. Yeah, let's say the implementation accepts a command list, a pointer to the command list, and you're just accepting this pointer and you're putting it like you're classifying this pointer, right? And then you want to okay, so to the command list itself, this is scanning here. We don't care about that. We don't care about that. Get command, yeah, core cast command list from the command list. So you're giving executing a command and you're casting it to the command list. Since you are already no, you already have this execute command somewhere. Yeah, it's already it's a bit different. This is a bit different. This is a bit different. It's a bit different. Create query. You are pushing. You want to create a query, but why doesn't? It's just this interface here. How are you supposed to do that? Let's look up at the other creators. Yeah, you see, there's this chain, and then what you're doing is swap chain makes self. Okay, you're calling swap chain makes self, and swap chain out is detach abi. The same thing we did, but how do you implement this? How do you call this? Yeah, you're calling this with just a pointer to that object. What? course you're calling this to the with a pointer to that object. Query implementation is not compatible with parameter type iQuery argument. What if, wait, can I do like something like just like cast that shit? Get address of get I don't know if get abs or something will work. Wow, I have no idea. iQuery interface. So this should work. This should work because we're creating here a query interface and we're detaching it. Whoa, what if I do like, if I do detach this obj detach Abby, and I do need an implementation out, but because it's as detached, then I don't need an implementation out. Detach Abby as. Okay, let's see. This create an event. Okay, let's see something that is my I have used this in the node engine here, but here there's these interfaces and you're not implementing some, you don't have an ABI implementation on top of that. You have an implementation. I can do this maybe for now I can just do this as get Abby, no, as iQuery graphics iQuery what is this implementation iQuery? No, graphics iQuery. But now calling as this doesn't work because you are calling something on a null pointer. No, there has to be a way to handle this, or maybe just create the, but the interface, you cannot create an interface here. Oh, you know what, you can maybe do something what was that create pen. So we have here think about, yeah, so pen here is this query and this is an interface here. It's not an implementation. Oh, so you're, can I just do that? This? I can do this. It's much simpler. Okay, yes, okay. And now here I can do query with just this. And okay, here I cannot now construct this. Since this construction is not valid. Visual Studio Code doesn't know that I need to look up the other query. Query implementation. This kind of query now can be constructed directly saying I can create an implementation, and then the base is like core I'm not sure how you're supposed to write this. So if I have here an implementation, here I have a query, main base. You essentially, okay, you do this, and this is a struct now. You can kind of say query equals obj. But no, the core make base object. I think this should work. This is Rust syntax. But I'm not sure. We'll see. I'm not sure this create base object. What does it do? It just creates a managed object, right? It should create just a managed object. Base of the implementation, which is this guy here. Base of the implementation, and you're forwarding the arguments, which is this. Okay, now that we have the query, we can go into DX control, and hopefully we have created a query. Man, that has been a fucking wild ride to create a single query. Hopefully here we have a query. Now that we have a query, we have to call the device context, and we have to begin the query. Oh no, D3D context, and then you begin, and you give. Oh, why is this like that? Oh no. Oh, this is something else entirely. Maybe something else in the OpenGL implementation. Oh no. So context should somehow begin this query, and why I don't understand why the context has to begin the query. Why not the device itself? Is that so fucking hard? So I have to write a layer here that like begin and end and flush are the are OpenGL commands. But look at this. Device from D3D has the begin command overridden, but of course because it doesn't need it. But here's the thing. This begin is my thing. No. So M context, then there's the begin, and it accepts ID3 D11 asynchronous pointer. It accepts a pointer. So but OpenGL doesn't accept this, and I have to write a separate function. And here's the thing, I can't even do that because this guy only implements this interface and doesn't implement anything else. Now how do I pass a pointer which is a device specific pointer? It's a platform specific pointer. I have to implement it here probably. Void begin query, and I have to implement, I have to give a query interface here, and then the query interface, so the query interface has to implement virtual what is this? What is even this? It's no, it can't be pointer because this is the pointer needs a type. Oh my god. This is how like you're developing something and you can't do that. You can't do that because you're thinking about how this whole infrastructure works. And this is not like competitive programming. There's nothing here. You're just thinking how to wrap your head around these pointers and these states and all. Like, who has to manage this, right? Does the device manage it? Does the query itself manage it? What is the query? Is it like a resource managed thing? Is it not? Oh, so I query. Oh my god, how do I handle this? Begin query. So I get a query, okay. But this is very specific query to D3D, you know? And this device context implements D3D stuff. So begin query. So I query could just like return com pointer ID3 D11 query which get query D3D query. And now when we implement this in the interface, like if there's some other interface implementing query, then just won't implement this thing, and that's it. I don't know what to say anymore. So where is this query? Where is this implemented? Query. You are always looking through the code. So iQuery implements this thing here. So as I said, it has to return this device specific pointer. Okay. And now in whatever the device was there, what was the device? Even device context begin query. Yeah, on the begin query thing, let's just write this function store commands, execute commands. There are all kinds of stuff here. This is tensile view, this is render view, this is device context. Okay, so let's do this here. Device context implementation. So we get the pointer to that query, and what we do is device create query. No, not the create query. Device begin. But what is the device? Oh my god, is the device just a device? Holy sh... It's a canny device. Oh no, not device, the context. The context is our context. There's begin, and then you are giving this asynchronous stuff here where you get this query, right? You're just, oh, you're pushing the query, not the pointer to the query, but the query, yeah, you're just pushing the pointer to, not the pointer to the pointer. Okay, yeah, so this is begin query, and then there's also begin query. There's also should be end query. Does it push again end? Yes, it does push again end query. Okay, and query. Okay, now that we know this stuff, we have to read the data from the context given a query. Now I'm thinking that it was better to just push the device context inside the query and define it like that, just if there is a way to do that, like push a pointer to the device context inside the query and just get the data from the query itself. Like, is there a way to push the device context inside the? I think there is a way. Like, where was this fucking query implemented? No, not here. Where is this iQuery? Yeah, instead of here, like instead of a pointer to that guy, you just push device iDevice context. And is it even possible to get a device from the device context? Is that possible? Let's say that like I have a pointer to the device context. Hmm. Is it possible to get a is it possible to get like context yeah, context create context device, get device. Yeah, I don't think it is possible, but we can expose the device on the context, I think. Get adapter. No, wait, what? The device needs a context, but iGraphics also, like there is also a device that you can implement a function that it will get the device, because it's all interfaced. Okay, for now it's easier just to do that. And later improve that. So let's just query and the device context itself. The device context is like combined here, and then you just like do void begin. You do void begin on the query itself, and then you say device context dot big m context get native target. You have to get a native thing, but there's no way to get a native thing, you know. Wait, what was the idea? The idea was, okay, we have device context, push and begin and end, but there is also this get data. Oh, and this get data is not an interesting idea. No, you have a query, you push a pointer to some integer, you push size, you push how much, this data type, depends on the query type, get data to be accurate up until the last. The call to end causes the data returned by the get data to be accurate up until the last call to end. I mean, I don't know. For now we don't have to implement this, but we have to implement. If we have to implement some kind of get data, because the context has to get the data. But what we can do is like we can do this. Get for now, because I just want to see if that works. Get data. I'll move that afterwards. I just need to know that this works. Get data and query. So you have this, what is this structure? Oh, it's a uint64. Okay, it's a uint64. Okay. uint64. And then you do context get data, and then you do query get d3d query, and then you do some like result. uint64, what is this? Size of, and this size of uint64, let's use with a t, because I like this Microsoft thing. And then while sok is not this, and then there's like some vector of uint64t result, and then result.pushback. No, this is the vec, and this is there some buffer. Why does it have to be a buffer? Why does it have to be a fucking buffer? Why not a pointer to some structure? Buffer. This is buffer. sok is some macro buffer. Okay, yeah. Oh, does it return just one int, or does it return many ints? I think it returns many ints. It should return many ints. Return by get data. What is get data? Get data is the size of data to retrieve or 0. Optional flags. So maybe like you could return or maybe must be 0 when p data is null. Get data flags. Another thing is like, do we have a pointer? Yeah, this is the pointer. Address of memory that will receive the data. Return value. This method returns one of the 11 return codes. Oh no, this is the return value. A return value of SOK indicates that the data is available for the calling application to access. A return value of S false indicates that the data is not yet available. Remarks. Queries in the deferred context are limited to predicate drawing. That is, you call get data to defer. You can only call get data on the immediate context to get data about a query. For predicate drawings, predicate type drawing used by the GPU and not returned to an application. For more information, no. But I'm not sure if like there's no saying like, okay, if it returns get data from graphical asynchronously. Yeah, so this is get data. Yeah. You can do whatever. You can supply whatever thing here. Essentially, you you can supply whatever point asynchronous pointer to that graphical interface, and then it will return the data. So it doesn't have to be a query, it could be anything. So essentially you could have anything. So asynchronous pointer. So maybe instead of iQuery we could have asynchronous pointer class interface. Yeah, that could be it. But okay, so now we can call this function from not OpenGL, but we can call this function here. So we could create a query, right? And what do we say here? We say this: begin. Oh, this is a device. Graphics. No, you can do this. Begin. What is this context now? Device context. Where did we implement these functions? Device context implementation. This device context implementation. There you go. These are the functions implemented here. So why doesn't it give us these functions? Begin query. It should give us these functions. iDevice context doesn't have these functions. No, why do you need iDevice context to have these functions? That is correct. iDevice context does not have these functions. Oh my, oh, okay. What? Can I do graphics device context? Doesn't have these functions again. So let's just for sake of this implement this in the interface. Let's just for sake of it implement all of these functions in the interface again. Just the signatures of these functions. Interface doesn't really need to create these functions, but there will not override virtual. What? Okay. Virtual is not allowed. Virtual it is allowed. Missing closing quote. What? Missing closing quote. It's not missing closing quote. What do you mean missing closing? Did I delete some namespace thing? No, haven't deleted anything. Okay, so now I can access the functions. Hopefully I can now access the functions, and now I can say this: begin and end query, and I can say d3d context get data, which is that query, and this is the data, and I just want to maybe just log this data. So just query data, and there is this data c.size, query data with this size, and then yeah, let's just lock the first element, data dot size data 0 or -1, whatever, something to see if something works. So this should be okay. Let's go and build this and see if we have any errors. We do have some errors. Let's just check these errors. Missing a semicolon, missing before, no, comp pointer is t. Maybe it doesn't have access to the ATL comp pointer. What kind of pointer does it use? Is this possible not to have access to the pointer? Okay, let's go like this. Pointer maybe it just needs something. ATL base. I don't know if I maybe it is better to just do core pointer, like from the core, because you have management as well. Yeah, let's do core pointer. There's no need to just yeah, query. There's no need to get ATL involved. Core does the same thing as far as I know. Like all of these are safe and thread safe things. I mean, this is thread safe, the other thing wasn't. Core pointer. Now the core pointer here should do the same thing. Oh no, now here create query could be changed. Well, when you're doing query, yeah, you're getting this is an ATL, but you're supplying a pointer here. What about just like this core? But oh, what about the? No, I'm not sure about the core. Not sure about how do they do it with the graphics. Maybe instead of the ATL, I can just use the Microsoft, the other type of shenanigans. Can I use the Microsoft, the let me show you what I mean. This comp pointer. Since we have it here, it should be available even there. But I don't know. Do they implement it differently? Do they have some other things that you need to do? I'm not sure. What is the comp pointer? Microsoft Like they're all the same, I think, just managed pointers. Whirl com pointer. Com pointer is part of the runtime C++ library and it's part of the active template library. But essentially it should be like this should be the same things. Even the core pointer should be the same thing. It's just inside, it just has a pointer to that interface. Yeah, so let's do a core pointer. We'll figure out how we just need to give the AB the detached pointer to there, and then that would be okay. I think it will be okay. Maybe. I don't know. I've never actually used the core pointer in conjunction with the D3D. Because you see, like this guy here, when you do get unsafe, and then you do this. Probably. What does it get unsafe does? It just returns a pointer. What does it want? This guy here, create query. No, this guy wants a yeah, pointer to a pointer. Get oh, the operator is not overloaded. There was this thing get address off. What you can do is this the com pointer of id3d 11 query com pointer. You can do probably this, getting to that com pointer, and then you can do this, and then you can do attach, and you can do com pointer. Detach. Detach from here and attach from here to here. I don't know, but I think this should work. I have to fix this. I don't like this kind of things, but I like everything to be on the com pointer. So maybe if I just overload the operator, the left operator here, the reference L value, yeah, this is overloaded. There is a pointer to the pointer. It returns this guy here, which is an overloaded of the operator. So why doesn't it just doesn't work that? Oh, it works completely fine. Yeah, it is an overloaded operator, so you don't need that. Okay, cool. Now that you have that, you want get create yeah, let's fix the other issues. Okay, create query, we fixed that. We fixed what was this? Okay, the implementation here, this guy is okay. This is implementation of this guy, core pointer. then begin query and end query, and this is just begin and where we get the query, and this is asynchronous. Yeah, this is just a pointer, and then there's this guy here. So okay, so let's just build this, see if okay. So doesn't like something. Add reference of AD query is not a member. Oh yes, okay. Yeah, because query expects add reference, this expects to be a min base. But you can just do counter now. Yeah, expects to be a min base. This is why this will never work. Okay, good thing we learned that. So in the core, pointers has to have a min base, but there was a structure. I will ask the colleagues. There was a structure where you could have a pointer which counts the references itself, but always we're doing it through a min base, so it doesn't so it's just yeah, you see, like there is this pointer, but this is a pointer to some kind of min base, which it can call this reference thing. So okay, let's just use the Microsoft VRL pointers. Let's just use that. I think this would be fine. If not, we will just add the okay, create. Now this here is also what? Why is this? Oh, so the oh Microsoft oh okay. I'll just go back to the comp pointers. Yeah, you see, like there are different kind of all of these like libraries. Some implement some structures and others don't. I just want to see where the errors are to go to fix them. Okay, so core pointer, yes, of course, this has to be comp pointer. Yeah, let's here we'll include ATL. Just I don't like to include it. I really don't like when I have to include ATL base, some other dependency, because it will get all, it can all crush down. Okay, so like, okay, the other thing is we get these pointers. What was the other thing that we had? Well, I'm too fast. I broke it too fast. Okay, cool. Wait. We need to fix this. OpenGL cannot instantiate class. All of this is very statically made, so oh, here we have some problem with the OpenGL because OpenGL doesn't implement this. Okay, we have to just write these things in the OpenGL class as well. Just where is the OpenGL class? Make self OpenGL context internal. OpenGL implementation gets the device context. Yeah, okay. Yeah. That's the thing here. That's the thing. It wants these to be implemented, but of course I'll just raise an exception afterwards. Maybe someday we can implement it for OpenGL as well. Get data must return a value. Yeah, I forgot where these have to be. No overloaded function accepts the. Yeah. Wait. This guy accepts a query and a context now. And we don't fucking use that context, so why do we need it here? Oh my god. No, comp pointer. Yeah, where do we make the scoped object? Yeah, because this is not a comp pointer. This is what I want to correct. Comp pointer. This is what I want to correct. What is treated as an error now? The following is treated as an error. Oh, return true. ID3D query is not a valid argument for type parameter. Wait, what? No, it should be a valid argument for this parameter. Proper usage of direct the direct resource view. Yeah, we have to maybe have to clean out some things later, but no, this should. I don't believe that this is not a valid argument for this is a class, right? And the comp pointer gets a base, and the base essentially t. And what it does, it type defs this pointer class t, and what should just do is this. Simple. Oh, it could be the fact that I cannot access here. Oh, that it is. Where does this live here exactly? Where is this D3, D11? Yeah, I have to think about this because I don't like the interfaces being accessing this kind of stuff. Oh, I don't like this, but okay, just for testing purposes, Well, how it will be different from Unreal Blueprints? Oh, well, it's Unreal Blueprints. I don't know how actually they work internally. But this is very different, I think, to like most of these Unreal Blueprints. Since all of these functions are mostly like in separate DLL files, and like you can hot reload stuff, so you can like work on some function in some DLL file. You can just hot reload this exact DLL file, and you just build the DLL file, hot reload it, and you have access to the new thing. And yeah, I've seen mostly all of these like all of these engines, but I don't know how they work from inside. These, I don't think you can. Can you create your own nodes? Can you create nodes in Unreal Blueprints? New nodes are added to a graph by selecting. No, is it possible to create nodes programmatically? This is my question. So like, you know, some coding, and is it possible? It is probably possible, but I don't know how they work on inside. I'm not sure, because this is like all statically typed here. Like if you take a look, let me show you something that like Rust can't do. So no state into the DLLs. Yes, there's no state into the DLLs. You're just pushing through pointers through the DLLs itself. There's no state inside the DLLs. And let me show you something that like Rust I think can't do in other languages, but I really like. So let me just what was this, like in the node engine? So what you can do here is yeah, you can extend. Yeah, no, but what I was wanting to show you something. Where was that? Where did I implement this? Let me think. This is in node common. Let me just go here. Yes, so every node has like has a statically const UUID, and like if an implementation of some node changes, it is compared against this UUID. But also like these are like auxiliary nodes that are not in a DLL file. These are here in a DLL file. How do they look is very interesting to show you. Let me show you here. Yeah, so let's say this color mix node, no? It's really simple how they look in a DLL file. Like this is a part of the program itself, but it's essentially the same as a DLL file. So they implemented this data processor bridge, and essentially they implement a couple of things like name, description, interface ID, implementation ID. And how do they create just an instance of the node itself? But then there are defined inputs that you can define, like what type of inputs. So there's like an image property, there's like constraint value, and you can register these inputs either is optional or or just required, and give you some kind of default values as well. So like each node, and then you're calling a process, and the process essentially accepts some inputs and fills out the outputs, and that's it. That's so simple. Like all is this, like, okay, there are wrappers here, but essentially at the back of the thing is just like pure data, like pointers to pure data. And like you are accepting some inputs, and you dynamically these inputs, you're converting dynamically these inputs to known pointers. So like images, if you go to the image property, you will see that the image property is just an object, but it will be implemented as like an image object or a tensor object or whatever you have. And then you are just processing something and setting on the output some object. And it's like incredibly like, and this leaves stateless as on or in like the DLL is loaded. So if you change something here, you just reload the DLL into the same piece of memory for the interfaces, and that's it. You just call these interfaces again and again and again, And what I wanted to show you that like was really cool is this here. So like you can add your own serializers, and these serializers for nodes, but you can create some other auxiliary nodes, which essentially what they do is like help you with some auxiliary stuff. So these can have functions like, but they cannot. They can just live there on the graph just to help with something. But what is really interesting is if you define like everything as static, right? And everything is like const expression, and these are static functions. And if you want to add all of the nodes, what you can do is like you can do a tuple of all of these nodes, and you can call the std apply function if you want to add all of the serializers to some factory that creates these nodes. You can apply, you can call the add serializer function on all of the types of these nodes given this factory. And this is all statically. So like it compiles to a list of instructions that are called one by one. So there's no for loop, there's no nothing here. You're just going through the list of nodes and you're statically just calling this function, which is kind of cool. I mean, and there are static checks if like you mess up the all of these I mean inputs to the nodes. It's like all checked. And there's like these different types of factories of nodes which handle how nodes are created and deserialized and serialized, and how the metadata is handled, and all of this like through wrappers, and all of this like it's pretty much very safe actually. Like there's like there are checks, there are warnings, there are some like it's pretty good. All different variables, values, whatever. So now that we have, now what does this guy want here? What does this guy want? Why am I getting an error here? Can he care? I don't like these dependencies. I hate these dependencies of the can care. Like, I mean, fuck. Like they make so many conflicts with everything else. Oh my god, like I just want to get this dependency out of every project, but I can't, because like all projects were done that way from the beginning. These are used everywhere, and like, yeah. So now what is this image? Why am I seeing this conflict here? Syntax error. I remember this was some conflict that can care was done, but I didn't. If I go into here, I did not. I wasn't using any care things. So essentially, like, fuck. Like we added just this. We added just creating queries, beginning queries. We added. Oh, yeah, this implementation. This could have been broken. And the graphics could also. Here we did not add anything. Oh, we had D311, which does actually. Oh no. Yeah, but without D3D11, I cannot access comp pointers, right? I mean, where do they live? Where? No, I don't want that project. I want that project. What should I include the minimal dependency for a com pointer? Atala.com. No, Atala base. Atala base is the minimum dependency for the com pointer. Yeah, Atala base. Maybe, yeah, okay. Wait, no, not clean. Oh my god. Oh, we're gonna wait for years now. Oh, this is huge projects here. It's like 10 minutes compile time. No, you're not doing, like, this is incremental. You have to incremental. These are huge dependencies here. We have to break down this project, I think, in multiple things, but I don't even need to build the whole solution. I just have to build this one project. But even building this one project takes years on my PC, you know. My PC is slow. So I don't let me just see here. Okay, we're gonna find some errors. Okay, I don't I want to understand how Unreal Engine treats the function calls and the graphs inside. Is there a way to see programming with C++? So information for programmers developing with the engine, coding standards, containers, delegates, Unreal reflection system. So they have a reflection system, but what is the reflection system inside Unreal Engine? That's interesting to see. Unreal reflection system encapsulates your classes with various macros that provide engine and editor functionality. Oh no, you are providing macros here to make the calls of these functions accessible. Encapsulates your class. Oh no, I don't like macros at all. Encapsulates that provides when programming with Unreal Engine, it's possible to have a standard C++ class and functions variables. The base class for objects is uObject. Okay, this is like what we have iObject. The same thing. Each class defines a template for a new actor or object. You can use uClass macro to tag classes derived from uObject. uObject handling system is aware of them. What is the uObject handling system? Like, why would you have a handling system? Marking classes and properties and functions property that turns new classes, new automatic property initialization or automatically zeroed initialization. Okay. Automatic update of references. When an A actor or A component is destroyed or otherwise removed from play, all references to are visible to the reflection system. Pointers are automatically nulled. This is beneficial. It prevents dangling pointers and present. Yeah, of course you'll have this, but interesting serialization, updating of property values, editor integration. So you speak. Okay, some virtual class. Runtime type information casting. Because uObjects are part of a reflection system, they always know what uClass they are, and type related can be made at runtime. Yeah, of course, but the whole idea is that it's kind of different what we're doing. Garbage collection. Yeah, why garbage collection? Why not just Unreal implements garbage collection scheme whereby objects that are no longer referenced or have been explicitly flagged for destruction are at regular intervals. The engine builds a reference graph to determine which I objects are still in use and which ones are orphaned. The root of the graph is set I object to designate root set. So they implemented their own garbage collection system. Is it faster than just when an object dies, it dies? Like, I don't understand what's the meaning. Like, why would you have a garbage collection system when an object is dead? It should be dead. Like, it should be, you should just clear it right now. Why would you clear it on a regular intervals? Maybe it just takes too much time to free memory, but free memory is just like so inexpensive call. When is free memory not? Maybe they want just to defragment the memory. That could be one thing. I don't know. What would you have? I don't know. Okay, errors. Cool. Yeah. Now this we couldn't access this kind of structure now. Yeah, this is the structure that we could not access, but I don't want to implement. I want to access this structure, not Kenny Care. Yeah, so if I access this structure, it somehow conflicts with the Kenny Care somewhere. And essentially I cannot access it from here, which is stupid, you know? Like, this is the only file that this structure lives, right? It inherits from this asynchronous thing, whatever that is. It has just one fucking function here. So there's no way for me to get this out. What if I don't implement this pointer here as a get query? Let's say I don't implement this. I don't implement it here on the interface itself. But on the query GeMMA puller, on the query implementation, I do it. But then I have to tell that this is specifically that, okay, so the implementation implements it, right? And now that I'm making this implementation up, create query is okay, it does work. Now begin query cannot get the necessary thing. Yeah, okay. Begin query cannot get this because this is not known at the implementation level. Can I do this? Graphics 3D. I'm not sure. Query. Maybe Q move pointer and then Q yeah, this query. I have an OBJ of this type, and now this OBJ of this type I can actually oh no, I cannot get this because this is not this thing here. Oh my god, it's so convoluted. Okay, let's think about this. The query Yeah, this I don't like to break the interfaces, but all of this is D3D, so nothing is going to be broken. Just this scanning here. I will one day just remove this dependency at all, because this is stupid. Everything can be done directly with calls to the D2D. There's no need for this scanning here. We should do directly all with calls to D2D. How much is this scanning here present? It's a lot. Yeah, fuck. That's a lot. That's not a lot. Does it only implement couple of things in from Canicare and just like, and we're using it? What does it implement here from Canicare? That's the point. That's the point. Using name. That's why I don't like using namespace. That's why in production you should not use using namespace, because now I don't know which functions are you using from Canicare here. It's like, which functions are you using? Better usage? No, better usage we have. Stencil operator, we also have that implemented. We have all of this stuff implemented. D3 filters, we have that implemented. I don't even think. Wait, can I just stash this thing here? Or maybe, I don't know. Maybe we just can go and like clean Canicare from like everything and just put it aside, and then it won't ever make problems again. Just clear everything the fuck from call like each of these functions. Yeah, let's just add a new branch. Let's see. Whatever stash. Let's see. Okay, so now I can go and I can remove this. Like, okay, let's now go build it, see if it builds. It should build, or it should not build. Device context begin. Queries, no, 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 no. That should not be it. Okay, and now let's go clean that thing up. Cleaning that thing up will save us probably, I don't know how big of that dependency is, but I know that this dependency, I know that it is big. There are some like, I mean, that namespace is just confusing. There shouldn't be that namespace. Okay, let's see. While we're here, let's see on the Unreal Blue. So there are actually node editors, how they're called. Not Node.js. There are actually like node-based editors that also like have like, there was one thing that I liked that I want maybe one day play out, to try out, to play with, is like the svelte thing, svelte flow. I'm a huge lover of svelte. Svelte, it's an incredible library. They, in honest opinion, in based honest opinion, they ruined Svelte with Svelte 5. But I get it why they did it. But the syntax, the Svelte syntax was much nicer on older versions. And now this like Svelte flow, I really like this project. I think this deserves kind of stars. It's still like really young, so it's not like even, but it allows you to do things with nodes. There was demo somewhere. Where was demo? Get ready from start. Like it allowed you to do things with nodes. It isn't quite like, you know, like I want to have different inputs and different outputs, and some here it's like not much like understandable why is this like that, you know. I'm more like the Blender thing, but I think this could be improved, and I hope that in like in some time that this can be improved. Svelte dev, yeah. Also there was Baklava JS. I have no idea. That one I haven't heard. Yeah. Cool. Vue.js. You have all these. This is the yeah. This looks much nicer. Because it like knows. But there was one that was low level Python, that you could just define Python functions and it would like know instinctively like the argument to parse the arguments, but I don't know. Python, no code Python programming. Lojo. No. But the whole idea is not to not have code. The whole idea is to make like simple stuff and reuse them, and give like people that don't know how to code, give access to like customization options. That, yeah, cool. Now that we have this, now we can start removing the care dependency just for fun. So if I remove this dependency from here, right? From here, this namespace, this will work. Okay, what? Why no? Let's remove it from like everywhere. Kenny care dx using bind flag, Kenny care bind flag. Yeah, just implement that bind flag and don't use it. So here there's this dx. The namespace makes a lot of problems here. Oh, here there's like a lot of stuff here that error out. Yeah, you're using resources here, and then resource, and then you have to implement that, and then you have to implement. Oh, whoa, there's the usage of all of these structures here. Texture 2D. The devices from Kenny. Oh, No, I'm not implementing all of these wrappers. Okay, let's merge with, okay, so this kind of, okay, this namespace we don't quite need using by. Let's see what else we don't need from this here. Yeah, when you're defining such things like that, define class, and then the macro itself defines some things inside, like it expands to some class. I mean, I don't like this. Okay, this is in dx. Static cast the dxgi format, and then there's like a bunch of these formats, but this is not even in the care, right? Is it? Is it? Is it? It is. Hum. Hum. Okay, wait. If I go from a com pointer to a weak pointer, but it won't have a reference. Okay, so let me just go into some other branch here. Remove Kenny. Like, I will leave that remove Kenny for other time, to just remember that I have to be doing this. And from this point on, I have to fix, I have to fix the pointers here. I have to fix that dependency. What was the dependency? The asynchronous, yeah, obj. So there was, yeah, so how to get away with not returning a pointer here? Oh, what if I just do this? I did 3D, just like a pure pointer. Yeah, you manage it inside the query, but you just return it. You just return ID3D. Yeah, ID3D we can't access. That's the whole point. We can't access that stuff from here. But OpenGL features we can. Oh, since OpenGL features are implemented here. So that's the whole point. We want to implement this. But okay, so what if I do this? Open obj get abi, and this will return. We can do get. We can do get abi, and then get abs, and then graphics d3d11 query imapala. Imapala. How was this get detach as, no, try as imapala, and since we have this, we can do imapala get this. I don't know if this will work. I'm not sure if this will work. I'm not sure, because try as converts the objects to what? Derived base type as an implementation. Well, you can cheat this. You can cheat this by just saying that I'm going to dynamic cast them, and I can do that, dynamically cast them. I can do this, and then derive the base. I can do this dynamic casting. I don't like to do that, but we'll just query obj get AB. Then I want to cast this into graphics that ready 11 implementation query implementation. I'll fix this later, just so I get a pointer here, just so I get a pointer at this thing. But I'll fix that because this is not how it's supposed to be. Will we get any back information is the question. I mean any GPU data. The query should provide us with timings, with accurate GPU timings. And now the thing is that there are two types of queries. There's the disjoint queries, and then there's like you're timestamping the there are two. There's query timestamp. Where was this? Great. Query descriptor, then type of query, and then there are two types, timestamp and disjoint, and I have no clue which one I want. GPU profiling in DirectX with queries. The difference between here, okay. Get a timestamp value where the get data returns a uint64. This kind of query is only useful if two timestamps of queries are done in the middle of a query timestamp disjoint query. The difference of two timestamps can be used to determine how many ticks have elapsed. Query time disjoint query will determine if the difference is a relative value and also has a value that shows how to convert the number of ticks into seconds. Determines whether or not D3D query timestamp is returning reliable values, and also gives the frequency of the processor, enabling you to convert the number of will return a oh my god, a different type of thing. When using this type of query, begin is disabled. What? Pipeline statistics gets the pipeline statistics such as the number of pixel shader invocations. This will be insanely interesting to see, but it does not return you in 16 always, or 64. Oh, it returns a data object. How frequently the GPU counter increments in hertz. Oh, so it returns how many the GPU counter increments in hertz. How many times per second the GPU counters increment. So this is a frequency. And then there's this idea, query timestamp, and then to get to the timestamp value returns a uint64. Okay. So the difference between these two timestamps times, so the equation is the following. So the difference, so we have end time minus start time is like count increments, and count of increments essentially here it gives you if this is true, sometimes occurred in the queries the calls keep the cost how frequently the GPU counter increments in hertz. Count incrementations, is that right? Get the number of get the timestamp value where this kind of query is only useful if two timestamps are done in the middle of a query disjoint query. The difference between two sides can be determined how many ticks have elapsed. We will determine if that difference is a reliable value and also has a value that shows how to convert. If that is a reliable value, what do you mean? This disjoint thing, if this is true, something occurred in between the queries begin and end calls that caused the timestamp counter to become discontinuous or disjoint, such as unplugging the AC cord on a laptop, overheating, throttling up and down due to laptop savings events. The timestamp returned by the get date is only reliable if disjoint is false. Oh, interesting. Count of hertz, count incrementation is, what is the dimension? Is this is just how many count elapsed, right? And the frequency is like 1/seconds, and we want this is 1, and we want to get seconds, so it's like count incrementation divided by the frequency. It's like seconds time. Interesting. Okay. Here we have to go and check. Wait, isn't this called? This is not called. Oops. Ugh, semicolon. Okay. So why is this not called? Oh, it's not called because we stashed them. No. OMG. So different kind of queries define different kind of things. It's unbelievable. You have to do so much work to just get a stinking what is this data from the GPU. So what is this block here? GPU profiling in direct 11. Mesh rendering 2 milliseconds. Mesh shadow rendering 0. 37 post processing. So you can, oh yeah, you can do different, like, and then yeah, when starting a profiling block, begin and pass disjoint query, and pass the start timer when ending, and the start timer and pass the disjoint query. After waiting a sufficient amount of time for the queries to be ready, call get data on all. After waiting a sufficient amount of time, this is probably like the while loop, that's why it waits a little bit. Get all of the 3 queries, compute the delta in ticks of the time from both queries, use the frequency from the disjoint query to convert the delta in time to seconds. Like any other query, you need to wait for the GPU to actually execute all of the commands you submit to the data wrap. In the sample application, what I'm doing is one disjoint query per frame, and many matched timestamp tokens in the frame. It seems to work fine, but sometimes I get fair values for the disjoint frequency of some older NVIDIA cards. Yeah. Okay, so this is exactly what we're doing. We're not using the disjoint query right now, but I just want to see if yeah, now still we get this idea of did we add something new to this guy? Why did we add it here? What was this idea? Yeah, this idea was D3D11. Yeah, now the query is not now this is not recognized because we have not implemented this. Since we don't quite since this query is somewhere other living, this dependency is making our lives a lot harder here in the code. Since this is the query, this is in the D3D11 implementation. And the 3D11 implementation includes this .x because it needs to be included here. But wait, isn't this included as well here? Or maybe we can just abstract this thing. No, this is not included. The draw engine, does it include? No, it does include D2D, but not DX. So we can abstract this kind of okay, so what we can do is we can do the following. Instead of having here things, we can abstract them onto the device itself and say, okay, like begin timestamp query, begin whatever, something else, like create a query, create like the device itself is just an interface here. Can we okay, this is yeah, so like, can I just do query here and like create query and like this graphics D3D D3D11 no, but what is this? Yeah, because query is like object, so I can just go graphics graphics query D3D11 query. Instead of this, I can just implement, I can move the query object to the graphics stuff. But is it even possible to do this? That's my question. Is it even possible to say, Okay, let's say that we create some query. Is it even possible to say create get obby create query? No. This is convoluted shit here. Because this is inside D3D, I have to do it from within D3D maybe. We have to do it from within D3D. Yeah, graphics device is... Does it make sense a graphics device to be implementing something that is platform specific? It does not make any sense to do that. But how do you define this? You just say device equals device, right? You initialize D3D. But when you are initializing D3D or whatever you're doing here, so you are saying D3D control. What? Not even initializing the, yeah, okay, D2D control, whatever. You still need to initialize this. Yeah, you need to initialize graphics the site, and get immediate context gets you the context, and this is the context. Graphics device is what? Initialized. Where is it initialized? Graphics device is initialized from the infrastructure where, like you're saying, create device. And create device just call some function that creates a device here. Debug device. Yeah, output the device here. Creates this kind of device with what? DXGI factory. What is this even here? Create device, add device, debug enum class, try convert device adapter internal adapter, device internal, graphics device implementation, initialize D3D11 device, and it like initializes this device here, right? You see, like it has some, or is it if you're initializing some translation layer? But essentially you're calling syscalls. No, it's not syscall, it's just some call to DLL. Only if we use DXGI swap chain. So let's return back to this. Okay. Let's return back to this. We have that. Let's go amend. Let's go here. Query. We want, what do we want? How do we want to compute? How do we want to make this happen? Like the query itself is an object, right? And this object is for now only specific to a D3D and not anything else, not OpenGL. So OpenGL could not create this object at all. But the whole idea, the whole problem is the following. You want to create this from within here. From within this context. So what I had is I was just calling create query here directly on the D3D graphics device. Directly calling this function. But you cannot do that. And there's no, yeah, let's standardize this. Let's say that the device will have a function that it will create a query, and this function will just return an object query given some specific enum or whatever. And this enum will now implement only like query timestamp and query this. Okay, cool. Let's do this. Let's do this. Where is this create query? Since there's no, yeah, we need to go to the device. We need to go to the device, graphics device. And on the graphics device API, on this here, we'll say the following: virtual void create query, and this will return a query object. This will return a query object, query out, and also we need like type query. This is no, it is not an interface, but some query type. Graphics. So we're in the graphics interface. Enum class query type. And there's like timestamp, there's disjoint, timestamp, disjoint, whatever. Now we're implementing these two query types. Oh, wow. Okay. And we're implementing type here. And this is pretty much all we need. Let's just do it in the graphics, just namespace, because I don't like this. And now that we have the device, who implements iGraphics device? That's now the question. iGraphics device. You just go through the code and you see that only one device implementation exists, right? And all of this is like D3D device implementation. So the only thing we need just to add is just create a query, and instead of this we do have this function exactly here, yeah, but it's not here, it's on the other side. So query type again, graphics query type, yeah, let's return boolean. Okay, query out, query. Boolean. Now that this matches with the, it conflicts with the other type, you have to think about this. Now here you have to think about what is the query type that is implemented here, and it's like we need a switch here, but essentially what we're doing is D3D query D3D11 query type. No, what was the what was the descript? What did the descriptor want? The descriptor wanted this. Query d3d query, and now you can just switch that and say switch query type, and say in the case that graphics query type timestamp do one thing, and then there's like case graphics query type timestamp disjoint do like the other thing, whatever that is, and like default is just return false. This is return true and return true. We need to implement these types here. This here would be like d3d11 query, and then timestamp this. Let's move this to the timestamp, since this joint is a little bit different. Okay, return false. And now one more thing I have to do is I have to go here and remove this, and now I can access directly int is explicit type is missing, int is assumed. What do you mean? Okay, let me just first go and say, okay, create query. We said that this kind of cool. Okay, so create, I have to implement that, but essentially this here is implement that is overridden, and there is another. Yeah, so now mdiv why did they change this here? Okay, so let's just do that. Okay, so this works. Query type, this works. This here we return query here, and this is a little bit questionable. Should return query, I just don't know why. Yeah, because query is not defined where we have to define that. That's why. So query type is defined in the graphics interface, and now we can say type here, but query is not. Yeah, it's defined only in the D3D implementation, which has to be moved to now to the graphics device or something. DXGI graphics device get query. What is this here? Graphics device can have these functions here. Namespace imapolo. This can be here, and then query can also, the main base object can also be here. Okay. This I don't know how to we'll see how to implement this. And is it even in the context? But we have to finish the work there. Here. Now when we create the query, do we want to actually create like a object here? Yeah. Create query. It returns a query implementation object. Detach SI query. Okay, let's see here. Okay, let's see here. What do we have here? This is now this. Oh, now we can call d3d device, and now we can create query directly here, and we can give a type of the query directly. And now we should get a query, a timestamp query object start. Let's say timestamp start. This now should get us the query, but we should start it up. So did the 3D context begin query timestamp query. Can I just push that query inside here? Since timestamp is graphics query and timestamp start query is I object, I can just do that, and I can do that, and I can do that, because it's all I query. Nice. Now we have to implement this kind of structure. This we have to implement. Since this is I query, this is graphics query getting the I query, and now obj dot big there's nothing until we get to the implementation. I don't like this, but we'll make this work for now. Okay. The other things are undefined. Okay. So now we should not have problems. Maybe we should wait, I know. We should remove com pointers and all this kind of stuff. So this is not defined. What if I define dx here? Does that work? Okay, so what is this here? Create oh, this is not correct. Wait, where is this? Oh, mDevice get obby, create query, query, and then this is query, and this is type. And now we can just do graphics query. Query is a null pointer, and then return query here. Does that finally work? Does that finally work? Wait. Does cannot yeah, okay, stops class, this could be fixed. This should be fixed. Wait, why cannot initial? What did I add? What did I add to the abstract class here? Does anyone know? Device iGraphics device. Yeah. Okay. Great query. Okay. Okay, let's add overwrite all of these. Okay. Must return a value. Return false. Did we get it? After 4. What? No way. This is insane. I think we get it. I think we got it. I need to clear it up, but pretty much I think we got it. Now that we have the timestamp, now it's very easy to implement for the other things as well, and get like the frequency and get everything from the things. Essentially we didn't get it. Again, this imaging fact. Oh my god, I have to see what is going on here. I have to see this. This makes a lot of problems. Image parameters. On syntax error, identifier image parameters. Why? Would love to use here base struct base struct cannot be defined. But why does this even matter? Why does this even matter? Why does this even matter? It's all inside the canny. This should be even like thrown out of the window. This is the base tract, and what is this expanding line? Holy shit. Yeah, just simple stuff. Oh my god, why does this even matter? So cannot include this here at all. How can I include the the com pointer without including this? Com but include no, not the computer. No, not the computer. We wanted to include something else. This query inclusion. This thing here. Include. Where does this live? include header. This header, can I include this header without the, yo, I can include it from that header maybe. Oh, is that the fix? So dx, yeah, then why do we have this dependency? We can't use it. Here, this dependency and this dependency and this dependency, it just cannot be used. And why is this in the source? It's in the source of frameworks graphics in the PCH. It's in the precompiled header. I don't understand. If it's if it's in the precompiled header, why can't we use this? What clashes when the is the precompiled header using another thing? No, it's the same function. Okay. Okay, I think we got this. I think we got this. I think we got it. Come on. I think we got it. Okay, why is not called? Why is not called again? Why is not called? Do we have any dx control? Create query. This should be called. This is called. So let's go inside. Let's go inside. Let's go here. It does create a query. The status is okay. So you're getting okay, yeah, that's null pointer. That's the pointer from the DLL itself. Now that object should have one reference and should have it should have a pointer, yeah, to an address, yeah. Okay. Okay. The pointer, okay, whatever. We don't care about that, whatever. End query. And now get data. Let's see what happens in get data. Result is empty. Buffer is like whatever. Query object is this. It gets an ABI. Okay, yeah. It gets to the buffer, but it pushes some format. Okay. Pushes two things to the buffer, but I'm not. They're the two. I think they're random. I don't think that's something they get. Okay, whatever. The data is here. Then data size and data and query data. But why a platform debug? Why doesn't it debug it? is platform debug turned off in graphics? It could be turned off, you know. What was the debugging here? I mean, I don't, let's say warning. Yeah, let me just. Okay, I will have to go because it's 8 o'clock, but yeah, okay, so we're getting something here, but wow, the size is what? Why is this so big? The size. And like all of these are like this is random, I think. This is random, definitely. Yeah, it waits until it's okay. Is that the case? Is that the case? I don't know how this is done, but is that the case that this waits? Where was this guy? Where was this guy? Where was this guy? Query data timestamp example. Profiling. Where was this example thingy? Begin and okay, so you're getting context, retrieving data. Oh my god, it waits. Getting data on the disjoint, it waits until it is equal to false. Wait a bit, but give the other threads a chance to run. It waits a little bit, and then what does it do? It gets data again. Query disjoint. Wait a little bit and then get the data. So what? Okay. So let's go here. Let's go get data. And let's say if it's not okay, I will just wait. If it's not okay, and then I will go and I need to retrieve the data again on the buffer, and I'll need to push back the on the result itself. While it's not okay, it's like waiting for the data to come. Should probably sleep. Of course, we will need to sleep. But the whole idea is that you have to. Okay, let's see. Yeah, now you see the timestamp going up. Now you fucking see the timestamp going up. I don't know how. Yeah, let's go. Let's go. Let's go. Let's go. Here, these are the ticks. It's it's incredibly precise. Probably it's like, I don't know, it's probably micro fucking seconds precise. Okay, cool. Now we have this data, and with this data we can get next time working. I mean, I will work off stream, but next time I will show you how we can measure like whole, like individual draw calls. We can measure with this thing, we can measure individual draw calls, and that's insane. That's insane. Yeah, D3D is no joke. But this here, this convoluted thing is also very very complicated to write. It's not a lot of code, but it's so you don't even know what conflicts you can make inside. But okay, so we have the query. We have, I don't have time. It's already 8. I want to stream a bit more, but I don't have time. It's been 4 hours. It's been 4 hours dealing with this and dealing with all of the other garbage. So the point is this the point is dx should not be included directly, and I don't know why is this included in the precompiled header. It's included in the precompiled header, and yet it does not. I don't know. I have to ask about this here. Why is it, I mean, why can't I include it somewhere else? But whatever the case is, we have timestamping right now. We will I'll fix the disjoint timer, and I'll fix the way we handle query objects. I don't like having this here, just creating an interface and then detaching it as iQuery. It could yeah, I mean, I don't know how that better to do it. Maybe just, yeah, I don't know. And this, I don't quite like actually what I wrote for the begin and end queries, but this is kind of just to see that this works. This thing here is kind of, I want to rewrite this from the perspective of, okay, the device context has to accept the query where to begin, but also the query can like accept the device context and do a job on its own. So that could be another way of looking at stuff, right? So query accepts the device context and just works its magic when you call begin and end. That could also be the case. Could also, yeah, that I'll change that. Thank you guys so much for joining in and seeing how in production, how it's like how we're coding stuff. And this is not C++, this is not actual competitive programming, but next time we'll do something again interesting, something maybe we'll learn some other API, how they work. And yeah, now you saw how cumbersome this D3D thing is, but it works. It's pretty nice actually when you wrap it around. So yeah, thank you guys so much for watching, and I see you probably in